Hello everyone, welcome to the next lecture on Centroid. Every particle on the universe is attracted by Earth with a force proportional to its mass. That is, this W is proportional to mass m, and we can write that W is equal to mg. So the weight or forces forms a system of parallel forces as shown in this figure, the center of which is termed as center of gravity. Center of gravity is the point through which entire weight of the body is assumed to be concentrated or acts vertically downwards. A body will always have only one center of gravity for all positions of the body. This is denoted by G. Whereas centroid is a point through which entire area of the plane lamina is assumed to be concentrated. So centroid refers to plane figures only, like rectangle, triangle, circle, etc. While center of gravity refers to solids. So we can say that here center of gravity depends on weight, and it is denoted for solids, whereas centroid is for areas and for planes. Now here you have to understand that centroid and center of gravity is always same for a plane lamina. Now we will discuss what is the centroid again. So if you consider any object or any plane, let us for instance take a circle, its centroid is denoted by G, whereas the distance from the reference axes, this x-axis and y-axis, that is x bar and y bar, are the horizontal distances of the centroid. So if the centroid of this circle lies at point G, then x bar and y bar represents the horizontal distance and vertical distance of the centroid respectively. Now we will discuss centroid and center of gravity of some of the common plane figures which we will come across. So for a square or a rectangle, the centroid will be at a point where the diagonals meet or the intersection of lines joining the midpoints of opposite sides. So this will be the G, or the centroid or center of gravity. And for triangle, it lies at the point where the three medians meet, right? So this is the point G. And for circle, simply the centroid or the center of gravity will lie at the center. Now, in order to solve problems on centroid and in order to understand the centroid and center of gravity better, we have to understand the concepts of axis of reference, centroidal axis and symmetrical axis. So these are three very important concepts. Now axis of reference, always this centroid is expressed with reference to some axis. So that axis can be exactly here or somewhere here, and it depends on the axis which we are referring to. Now if you consider this circle, I can take the leftmost and bottommost part of this particular section as the reference axis, or also the object can be here and this would be the reference axis. So the difference here is you are measuring x bar from this particular axis itself, whereas here you are measuring x bar from two different points. One is the distance between this axis and this point, and the x bar or the centroid of this object which you are measuring from this point. So that is the importance of axis of reference. We'll understand it better when we are solving problems. Next is the centroidal axis, the axis which passes through exactly on the centroid. So this is xx and this is yy, which is passing through the centroid of this rectangle, that is G. And now coming to symmetrical axis. Now symmetrical axis is nothing but this is the axis. If you cut along that axis, it will form two equal parts. So if you take this triangle, and I am drawing this symmetrical axis here. So if you cut along this line, the object which is on the left hand side will be similar to the object on the right hand side. So this is symmetrical on y axis, right? So again similarly, if I cut an axis in the horizontal direction, it will not form a symmetrical axis because the object on the top and bottom is not similar, right? So if you take this rectangle, it is symmetrical both on xx and yy axis. Now I have some objects here, so we will discuss. So let us take symmetrical about both the axes. Now if you take this rectangle, I can cut along x and y. The object which forms on both the sides will be same. So this object is symmetrical about both the axes, that is xx and yy. Similarly this circle, symmetrical about both the axes. So what about this I section? So now if I am cutting the object along this particular line, so whatever on the left hand side is similar to the point object on the right hand side. So what if I am cutting in the horizontal axis? Again it is same, right? So that's why this I section is also symmetrical about both the axes. Now let us see some objects which are symmetrical about YY axis. So this T section, cut it, so symmetrical. So this direction symmetrical, this direction symmetrical. If you are cutting in this direction, symmetrical. Try cutting in horizontal direction. So if I am cutting the section like this, it is not symmetrical, not symmetrical, not symmetrical, and not symmetrical. Now symmetrical about XX axis. Now these objects are symmetrical in X axis. So if I am cutting a section like this, it is symmetrical, right? Symmetrical, and it is not symmetrical in the other way. Now let us discuss the formulas for centroid for some of the very important planes which we will come across. Okay, so if you consider a rectangle, centroid will lie at a distance of x bar in the horizontal direction and y bar in the vertical direction, that is b by 2, b is base, and h by 2, that is height. So if you want to understand it better, so if you take a rectangle like this of side 2 meters and 1 meter, and if you take this as the reference axis, x and y, alright. Now, so what is the centroid? This is the centroid, correct? Sorry, G. Now this distance, so this is the this distance we have to find out. So as per the formula, it is b by 2. What is b? 2 by 2, that is 1 meter, and this is h by 2, so height is 1 meter, so 1 by 2, that is 0.5 meter. So x bar is equal to 1 meter, y bar is equal to 0.5 meter for this rectangle. So similarly for this triangle, if you take the reference axis here, so it is x bar is equal to b by 2 in horizontal direction and y bar is equal to h by 3 in vertical direction. Similarly for right angle triangle, it is h by 3 and b by 3 from this axis or from this portion of the triangle, that is important. Similarly for circle, it is if the diameter is d, so it is directly d by 2 and d by 2, that is exactly at the center. Okay, so for semicircle, it is x bar is d by 2, that is in this direction it is d by 2, and y bar is equal to 4r by 3 pi. So this is important. Also for a quarter circle, both x bar and y bar are 4r by 3 pi. And also you have to note the areas of all the important shapes. So sorry, this is base into height, area is base into height. Here area is half into base into height, half into base into height. Area is pi r square by 2 and pi r square by 4. Now I'll explain the centroid of this semicircle with an example. Alright, so there is this semicircle, correct? And we want to determine its G. So where is this G? So first let's take this as the reference axis, x, y. With respect to this reference axis, I am going to find out the centroid G of this semicircle. Now what does our formula say? It says x bar is equal to d by 2 and y bar is equal to 4r by 3 pi. So let's say the radius is r, alright. So this radius is r. So this x bar is equal to how much? D by 2 or simply r, and this is 4r by 3 pi. And what if this semicircle is at a distance of some meters like this, and this is your reference axis, x and y. Now remember, this is r or d by 2 and this is 4r by 3 pi. but you need the centroidal distance with respect to some reference axis, right? So now this you have to add this particular distance, let's say P, and this particular distance, let's say Q. Now X bar will be P plus R, right? And Y bar will be Q plus 4R by 3 pi. That is important. Now you'll have to memorize all these formulas, which are very important in solving problems. In the next lecture we will solve some problems based on centroid.